Welcome to BKW Physics. I'm Mr. McConley, and I have a demonstration today. It involves these two spheres that are black, they're rubber. And there's one thing that's very different about them that you can't tell by just glancing at them. They kind of look the same. So I guess the best way to do this is actually just to do the demonstration. So I'm going to drop these two at the same time to the tabletop, and I want you to watch carefully what happens. Okay, watch that again. Yeah, this one really didn't bounce. This one bounced like a normal ball that you would expect. Where this one, you watch it separately. Very, very different the way they react. But backing up to what we've been talking about, both of them have to have the same potential energy because they required the same work to lift up because they're the same mass. So they required the same work to lift up to here. They have the same potential energy once they get here. And when I drop them and they're basically at the height of the desk, they have the same kinetic energy. So, where did the energy go? Because we know from our conservation of energy discussion that energy cannot be created or destroyed, it can only change forms. That's a law of conservation of energy. So, when they both hit the table, they have the same amount of kinetic energy, and this one retains a lot of it and bounces, and this one, quote, loses a lot of it and kind of remains on the table. So, a lot of you are jumping to the idea that, okay, yeah, well, we did that equation where you can have Q, and Q was called internal energy. So, listen this time, listen, and you might not be able to hear it on the video, but listen to this compared to this. Which one's louder? The one that doesn't bounce. So right there you've lost more energy because that thing's loud. Now if you were able to zoom in with a really high-tech camera and watch this, as this hit the table, you would also notice that this ball hits the table and goes brrr, brrr. So it deforms a lot. Whereas this ball does not deform much and it just springs off of the table. There's a name for this. This one is an elastic collision. Elastic, like elastic rubber band. It bounces well, it's elastic. And this is inelastic. Okay? And this idea also applies when you're talking about car crashes. When you crash a car into another car, the cars crumple up, and sometimes they crumple up and just kind of stop. You know, they just go crunch and they stop. And this is an inelastic collision. But then you think of if you're playing pool, and you play pool and two billiard balls hit each other, they'll go doink, and they'll bounce off of each other in a very elastic collision. It doesn't seem like any of the energy was lost. So what basically we're learning about here is that other form of energy, that Q, definitely comes into play at times, and you can see beyond a shadow of a doubt that two balls that look like each other do not react the same because of their makeup. Today, that's physics.